The slope of a line is a kind of indication of the steepness of the line. Okay, it can be defined as the ratio of the vertical change to the horizontal change as we move from point to point on a line. Let me give you an example. Let's say we start with the equation y equals 2x plus 1. Here we have a first-degree equation in two variables. In the last videotape, we learned that the graph of such an equation is a straight line. Okay, let us try to graph this line by plotting a few points. Okay. Here are our coordinate axes. We can make a little table in which we'll use this table to calculate some of the points on the line. For example, let's let x equal -1. If x is equal to -1, let's figure out what y would be. X equals -1, we'd have -2 plus 1. Y is equal to -1. Okay, then we could let x equal 0. If x equals 0, y would be equal to 1. We could let x equal 1. If x is equal to 1, y would be equal to 2 plus 1, or 3. And finally, we could let x equal 2. If x is equal to 2, y would be equal to 4 plus 1, or 5. We know that 2 points determine a straight line, but I plotted 4 here just to be sure that we have the right thing, let's say. Okay, now let's plot the -1, -1 would be about over here. 0, 1 is over here. 1, 3, that would be 1 over 1, 2, 3 up. And 2, 5, 2 over 1, 2, 3, 4, 5. Okay, and it certainly does appear as if these points do lie on a straight line. Let's try to draw this. Bear with me here. I don't have a ruler. Okay. Here is -1, -1, 0, 1, 1, 3, and 2, 5. Let's label these points A, B, C, and D. Okay, now I am interested in computing the slope of this line. Okay, let's work with points A and B. I mentioned earlier that the slope indicates something about the steepness of the line. Okay, it's a ratio of the vertical change to the horizontal change as you move from point to point. So let's say we were moving from point B to point A. Okay, from point B to point A. We have, in other words, we're moving like this, but you could think of it as a certain vertical change and a certain horizontal change. In other words, we move to the right 1 and up 2. So the slope as we move from point B to A, we have a vertical change of +2, which is coming from the 5 minus 3, over a horizontal change of 1, 2 minus 1. And we have 5 minus 3 over 2 minus 1, 2 over 1, or 2. Okay, let's go over that idea. A vertical change over the horizontal change. This point, comparing, in other words, point A to point B, point A is 1 over and 2 up. And how did I figure that out? I said if I'm going from 1 to 2, in other words, my horizontal change is 2 minus 1. It is +1. If I'm going from 3 to 5, my vertical change is 5 minus 3, or +2. Okay, now suppose you were to take a different starting point. Suppose you started at point A and you went to point B. From point A to point B. Okay, let's measure the vertical change and divide by the horizontal change. Going from A to B, we see that we are going from 5, from a y-coordinate of 5 to a y-coordinate of 3. The vertical change is therefore 3 minus 5, or we are moving down 2, minus 2 for the vertical change. We then go from an x-coordinate of plus 2 to an x-coordinate of plus 1. So we're going to the left 1 unit. It's 1 minus 2. So we have a vertical change down 2 over a horizontal change to the left 1, minus 2 over minus 1. We once again get plus 2. It doesn't appear that it would matter which is your starting point and where you end up. Let's try another 2 points. Let's say we were interested in computing the slope as we moved from point D to point B. From D to B. Okay, here's D and here is B. To go from an x-coordinate of minus 1 to an x-coordinate of plus 1, we have a horizontal change of plus 2. That is 1 minus a minus 1. Where we end up, minus where we started. 1 minus a minus 1. Here the y-coordinate at D is minus 1, and the y-coordinate at B is 3. So we have a vertical change of plus 4. In other words, 3 minus a minus 1. That's 4 over 2. Once again, we get 2. Okay, why don't you try one of these? Try working out the slope as we move from point C to point A. You can shut off the videotape machine and work it out and turn it back on when you've completed this. Okay, let's see what we have. We want the slope as we move from C to A. We have a vertical change. We're going from 1 to 5, a vertical change of 5 minus 1 over a horizontal change of, we're going from 0 to 2, of 2 minus 0. 5 minus 1, that's 4 over 2. Once again, we get 2. In other words, going from C to A, we move to the right 2 and then up 4. Okay, now, it's not coincidental that we got the same answer in all of these cases. The slope is a property of a line, not of the 2 points on the line that you choose to use to calculate it. Okay, it is a property of the line. It measures the steepness of the line. And it doesn't matter any 2 points on the line. If you were to calculate the slope of the line segment connecting those 2 points, it would always come out the same. The slope is a property of the line itself. It doesn't matter which 2 points or where you start and where you end. The slope of the line will not change. Okay, let me give you now a formal definition for the slope of a line. Definition. The slope, and we usually designate it by the letter m. The slope m of the line passing through the points x1, y1, and x2, y2 is given by the following formula. M is equal to y2 minus y1 over x2 minus x1. The slope of the line passing through these 2 points is given by this formula. Now, it doesn't matter which point you consider to be the first point and which point you consider to be the second point, but you must be consistent. Okay, if in this problem over here, I'm trying to find the slope of the line, and I'm using the points A and B. It doesn't matter if I call, say, point B x1, y1, and point A x2, y2, and get for my answer y2 minus y1, 5 minus 3 over x2 minus x1, 2 minus 1. Or if I had reversed these 2 points, and I would have gotten, say, 3 minus 5 over 1 minus 2. Okay, but it is important that you be consistent. Make up your mind which is the first point and which is the second point. If you're going to measure the change in y, say, starting with this point, this y coordinate minus this one, and you must measure the change in x, okay, the horizontal change, by starting with the same x coordinate minus this one. Okay, you must do it in the same direction. So it doesn't matter which is your first point and which is your second point, but you have to be consistent. It's going to be the y coordinate of one of the points minus the y coordinate of the other point divided by the x coordinate of the same point that you started with here minus the x coordinate of the other point. Sometimes we write this as delta y over delta x, meaning the difference in the y values over the difference in the x values, or the change in the y values over the change in the x values. By the way, this can also be thought of as rise over run. The vertical change is thought of as the rise. Okay, let's go back over here. y2 minus y1 is sort of the rise. The difference in the y coordinates represents this distance here. And the difference in the x coordinates represents this distance here. So it's the rise over the run. Okay, going from B to A, okay, how much of a vertical rise you've taken divided by how much of a horizontal run you've had. Okay, so here we have the formula for the slope. Okay, you might notice that we would have trouble if x2 were equal to x1 because we'd have division by 0. So for the time being, let me just say that the slope of a line is given by this formula, provided x1 is not equal to x2. We will see the implications of this a little later on. But right now, I'm assuming that x1 is not equal to x2. Okay, we figured out the slope of this line. Regardless of the 2 points that you pick on it, the slope of this line turned out to be 2. You might notice that the number 2 appears in the equation of the line, and this is not a coincidence. We'll see another example that's going to happen again. In the next videotape, we will learn the relationship between the slope and the equation of a line. Y equals minus 3x plus 2. Okay, I'd like to repeat the procedures that we did in the first example. I want to plot some points. Okay, we know that this graph of this is going to be a straight line. Let's get some points in a little table. Okay, let's try x equals minus 1, 0, 1, and 2. And figure out the y values. Of course, you could do this on your own. What I'm going to do here is to plot some points and work out the slope of this line. If x is equal to minus 1, we would get minus 3 times minus 1 is plus 3 plus 2. Y would be equal to 5. If x is equal to 0, y would be equal to 2. If x is equal to 1, you get minus 3 plus 2. Y would be equal to minus 1. And if x is equal to 2, you get minus 6 plus 2, minus 4 for the y value. Let's plot these points. We have minus 1, 5. 0, 2, 1, minus 1, and 2, minus 4. And we will draw a straight line through these points like that. This is the graph of this line. Let's label these points A, B, C, and D. A is the minus 1, 5. B is 0, 2. C is 1, minus 1. And D is 2, minus 4. Let's work out the slope of the line passing through points A and B. And also we'll work out the slope of the line passing through points C and D. And of course we would expect the slopes to be the same since these are all part of the same. These points all lie in the same straight line. But just to show it to you one more time. Now, the slope formula that we have is y2 minus y1 over x2 minus x1. Okay, as we go from A to B, y2 minus y1. Let's let point B be x2, y2, and point A, x1, y1. So y2 minus y1 means 2 minus 5 over x2 minus x1, 0 minus a minus 1. 0 minus a minus 1, giving us minus 3 over plus 1, or minus 3 for the slope. Remember, once I decide to go 2 minus 5 for y2 minus y1, then I must go 0 minus a minus 1. You must start with the same point that you started with the y-coordinate, you also start with the x-coordinates. Okay, so we get the impression that the slope here is minus 3. Let's work out CD, the slope of this line segment. Okay, we could let this be x1, y1, and this x2, y2. So y2 minus y1 will be minus 4, take away a minus 1, over x2 minus x1, 2 minus 1. Minus 4 plus 1 is minus 3. 2 minus 1 is 1. And once again, we get minus 3 for the slope. So the slope of this line is minus 3. Notice that minus 3 also appears in the equation of the line. And as I mentioned earlier, this is not a coincidence. Let's go back to the first example. Here we had the line had slope 2, and 2 appeared in the equation. Something else that you might notice, this line here is a rising line, so to speak. Rising lines have positive slope. Here the slope was plus 2. It was a rising line. Back in this example, this line, we could say, is a falling line, and the slope is a negative number. Falling lines have negative slopes, and rising lines have positive slopes. Here the slope was minus 3. The line was a falling line. Okay, as you move from left to right, the y values were decreasing here. The line was a falling line. Over here, as you move from left to right, the y values were increasing. The line was a rising line. Rising lines have positive slope. Falling lines have negative slope. I'd like you to find the slope of the line passing through the points 4, 5, and minus 2, minus 1. Okay, why don't you try that? Although you are not required to sketch the line here, it's not a bad idea to always make a picture, see what's going on. 1, 2, 3, 4, 1, 2, 3, 4, 5. Here's the point 4, 5. And minus 2, minus 1. Okay, so we have, sorry about that, certainly going to be a rising line. Okay, since the line is a rising line, we would expect a positive slope in this instance. Okay, now we can arbitrarily let one of the points be x1, y1, and the other one x2, y2. We can let this be x1, y1, this x2, y2. It doesn't matter which is which, but you have to be consistent. The slope is then y2 minus y1 over x2 minus x1. y2 minus y1, 5 minus a minus 1 over x2 minus x1, 4 minus a minus 2. 5 minus a minus 1, that is 6, over 4 minus a minus 2, that's 4 plus 2, that's also 6, and we get plus 1 for the slope. Positive number since it is a rising line. Okay, let's try some more examples like this. What about the slope of the line passing through the points? -1, -2, and 2, -2. Letting this be x1, y1, x2, y2. We get the slope is y2 minus y1 over x2 minus x1. y2 minus y1, minus 2, take away a minus 2, over x2 minus x1, 2 minus a minus 1. Minus 2, take away a minus 2, minus 2 plus 2, that's 0, over 2 minus a minus 1 over 3. 0 divided by 3 is 0. You have nothing, you divide it into 3 parts. Okay, each person gets nothing. 0 divided by 3 is 0. That's very interesting. The slope in this case turned out to be 0. Let's make a picture and see what's going on. We had the point -1, -2, which was over here, and the point 2, -2, which is over here. And when we connect these points, okay, we get a horizontal line, a line which is parallel to the x-axis. Okay, always the same distance away from the x-axis, never touches the x-axis. It's parallel to the x-axis. These 2 points lie on the same horizontal line. And it will always turn out that when you have a horizontal line, the slope will be 0. Remember, slope measures the steepness of a line. Okay, and here we have 0 slope. Okay, and then as we move off the horizontal, we get various, different slopes. The slope would say increase, or we could have negative slopes, but the point is 0 slope indicates a horizontal line. You see, if you have 2 points on the same horizontal line, they're going to have the same y coordinate. Okay, they're going to have to be the same distance down, say. If they have the same y coordinate, then y2 minus y1 will have to be 0. Okay, so this is always going to be true. Horizontal lines have slope 0. Okay, horizontal lines have slope 0. This will always be the case. Okay, let's try another example. Find the slope of the line passing through points 2, 2, and 2 minus 1. Okay, this is, let's say, x1, y1, and this is x2, y2. Now here an interesting thing happens. If we try to use the slope formula, which is y2 minus y1 over x2 minus x1, we would get minus 1 minus 2 over x2 minus x1, 2 minus 2, which is 0. Okay? Whoops. We can't have division by 0 in our mathematics. What went wrong? Remember when I gave you the definition of slope, I said provided x2 is not equal to x1. Because if x2 were equal to x1, we'd have division by 0. And here is an instance of x2 being equal to x1. Let me draw a picture and show you what's happening here. We have the points 2, 2, and 2 minus 1. These points happen to lie on a vertical line. We cannot use the slope formula here to calculate, okay, the slope of this line. Vertical lines do not have the property of, so we don't measure the steepness of the line. It's almost as if it was just infinitely steep, okay? Go over here. Remember slope originally I told you that it was the vertical change over the horizontal change as we move from point to point. So as we go from here to here, there was a vertical change of 0 over a horizontal change of 3. Here, as we go from here to here, we have a vertical change of, say, 3 over a horizontal change of 0. We cannot calculate that. In other words, there is no horizontal change. We're on the same line. These 2 points are on the same vertical line. There is no difference in their x-coordinates. Okay, so we will simply say vertical lines do not have this property called slope. Vertical lines have no slope. Now, please don't confuse this with slope 0. When I say vertical lines have no slope, slope is not defined. Okay, it's meaningless. Is not defined for vertical lines. They have no slope, not in the sense of 0 slope. They simply do not have slope defined. The slope formula is inappropriate. If you would like to think of it as sort of like an infinite kind of slope, where it's just infinitely steep here. Regardless, we do not talk about the slope of vertical lines. They have no slope. It is not defined for vertical lines. Okay, so we cannot use this formula. Over here, I showed you lines which were parallel. In other words, the line connecting these 2 points was parallel to the x-axis in the sense that it was always the same distance away from the x-axis. These lines never intersected. No matter how long you would, you would let them go in either direction, okay, they would never intersect. These non-intersecting lines in the same plane, okay, are called parallel lines. Here we have this line and the y-axis are, once again, parallel lines. Now, it sort of stands to reason that parallel lines they sort of have the same steepness. You would expect that parallel lines would have the same slope, and this is true. Let me give you this. These are really theorems which are not going to prove, but it's sort of intuitively obvious that lines which are parallel should sort of have the same kind of steepness. Okay. Now, I'm going to be talking here about non-vertical lines. Okay. We all know that vertical lines don't have any slope, so we cannot relate. Okay. Anything that talks about the slope of a line cannot apply to vertical lines. So we're talking now for non-vertical lines. 2 non-vertical lines are parallel. And the symbol for parallel would be like this. Okay? If and only if they have the same slope. Okay? As I said, the logic would be that if they're parallel, that means they're always the same distance apart, they are non-intersecting lines, then you would expect them to sort of have the same steepness. Okay, this one is a little to the right of this, but if you move this one over here, it would, in other words, fall on top of this line. These lines have the same steepness. If you were to measure, say, the steepness by the angle that they make with the horizontal, okay, with the x-axis, it would turn out these angles are the same. They have the same steepness. Okay, and vertical lines, of course, are always parallel to each other. Non-vertical lines, okay, have the same, if they're parallel, they have the same slope. Okay, an equally important idea is one which talks about the slopes of perpendicular lines, lines which meet at right angles. Now, this is not obvious. This one was obvious. In other words, it's sort of logical that parallel lines should have the same slope. What I'm going to write down now is not obvious, but it is true, and it can be proven. Two non-vertical intersecting lines are perpendicular, and the symbol for perpendicular lines is this. The lines meet at right angles, are perpendicular if and only if the product of their slopes is -1. If you were to consider M1 the slope of one of the lines and M2 the slope of the other line, then we would have the product of their slopes is -1. If you knew the slope of one line, you could solve for the slope of the other line. For example here, dividing both sides by M2, M1 is equal to -1 over M2. If the product of two numbers is 1, the numbers are called reciprocals. The product of two numbers is -1, the numbers are called negative reciprocals. So if I know the slope of one line, I can find the slope of a line perpendicular to it by taking its negative reciprocal. I could have finished this off if and only if the slopes are negative reciprocals of each other, or equivalently if the product of their slopes is -1. For example, okay, if the slope of a line is 3, okay, what would a line, we want a line perpendicular to this line, what would be the slope of a line perpendicular to a line that had slope 3? Its slope would be the negative reciprocal of 3. By that I mean -1/3. It's negative reciprocal, and the product of the slopes, of course, is -1. Suppose I were to start with one line, slope is -2. And I say, what is the slope of a line perpendicular to this? It would be the negative reciprocal, the negative giving you 2, and the reciprocal 1/2. Once again, the product of the slopes would be -1. Suppose the slope of one line were 1/4, and I said we were looking for a line perpendicular to this line. What would be the slope of a line perpendicular to a line that had slope 1/4? Okay, its slope would be the negative reciprocal. That would be -4, the negative and the reciprocal. And once again, the product is -1. And finally, suppose I start with a line that had slope -1/5. What is the negative reciprocal of -1/5? It would be 5. Negative and reciprocal. The product of the slopes would be -1. We're going to be using these ideas in the next videotape. Okay, so remember that non-vertical lines are parallel if and only if they have the same slope, and non-vertical intersecting lines are perpendicular if and only if the product of their slopes is -1, or if and only if their slopes are negative reciprocals of each other. And that brings us to the end of this tape.